Cecelia Martinez. I'm a community lead at replay.io. I will be taking a look at Replay today. It is a all-in-one time travel debugging recorder. It helps you reproduce and then also debug issues with your applications. As a community lead, I essentially work with all of our users to help people kind of better improve their debugging processes, learn how to use Replay, create examples, documentation, even through things like push code sometimes. So it's something where if you do end up coming across bugs in your application, which most people do, that's something that I really love helping people work on together. I think debugging works better when it's a collaborative process and you can throw ideas off of each other when you don't have your rubber duck handy. So yeah, so definitely feel free to use the BYOB channel in Slack in order to share bugs there and we can work on them together. But today I'm going to be talking about how to debug your debugging process. So developers spend up to half their time debugging and maintaining software. To you, that may feel like a lot. It may feel like an understatement, depending on kind of what application you're working on. But the important thing here is that everybody has bugs. If you have bugs in your software, it's not because you've done something wrong or because you're a bad programmer or because you don't know what you're doing. I've worked with teams at companies of all different sizes, all different levels of skill, and every single one has bugs that they have to deal with. And so, we spend a lot of time debugging and maintaining software, and it seems like nobody really likes to do it, or nobody really thinks of it as a fun process, right? So we see these like memes. I just did a debugging search on Twitter, and you see memes about just trying to stare at my code and hoping that it'll work, or not understanding what the call stack means, feeling like you have no idea what you're doing. And that's something that I think a lot of people experience. And what that comes down to is not necessarily having the best process for how you approach bugs. So you really need a process to debug effectively and efficiently. If you don't have a process, then you're going to have a bad time. And that's because debugging is very, very different than building. If you think about when you're building something with Legos, you have the pieces that you need, you build like your structure, you follow the instructions. But if something goes wrong, that's when things start to fall apart a little bit. And it's a very different skill set. And it's a skill set that you do have to practice and you have to approach with intention. So with a process, debugging can actually be a fun learning experience. And so that's something that we want to talk through today, is how you can apply a process to how you approach bugs, so that you can think of it as not something that you have to do or something that you're stressed about doing, but rather as an opportunity to get to learn more about your application, how it works, and why it doesn't work. So the debugging process that I like to follow, so these are going to be some practical steps that you can take to approach any bug that you encounter. I typically am debugging web applications, so front end primarily, but also can be coming from the back end. So that's the context that I'm coming from. But I wanted to give an abstract process. So this really could be used for any type of bug. If you encounter a bug that's kind of deeper into JavaScript or a different language or backend, you should be able to follow this process either way. So the first step is to reproduce the issue. And we'll be digging in more into what each of these means. But the first thing that you do need to have is a reproduction of the bug that's occurred. The next is to identify expected behavior. And this essentially means, what is it supposed to be doing? What do we expect the application to do when it's working? After that, then you define the problem. So being as specific as possible about what the bug actually is that's happening. Then isolating the issue, so narrowing down where it's actually occurring in your code. Tracing the root cause, so doing this, finding what's the actual culprit, what line of code is causing the bug, where the actual issue is, and then identifying potential solutions. So I've heard a lot of different types of approaches to debugging. I think we've all been there, where it's, you comment out one line at a time and see what works. If you're debugging CSS, I've heard the adding a one border a 1 pixel red border to every element so that you can see like where things are on the page, adding console.log on every line and rerunning it and seeing what happens, just deleting things, adding things in, changing multiple things at once. Those are all things that we've done and we've been there, but they come from a place of not really knowing how to approach it and from trying to just like throw spaghetti on the wall and see what sticks. And so hopefully by taking this more this is like more methodical approach, it'll be a better experience for you and you won't have to resort to some of those approaches. So the first thing we talk about is reproducing the issue. So recreating the issue in a debugging environment. So if somebody tells you, hey, it's not working, and you're like, okay, well, what's not working? Trying to get into the details of what the bug actually is. Chances are, if you're developing, you are actually encountering the bug yourself already. Maybe in your local environment, you can see that it's not working. Maybe something is broken while you're in the process of building it. So in that case, you already have it running on your local machine. But if you were to get a bug reported by somebody else and saying, hey, I'm getting an error here, or when I visit this page, the information's not correct, you need to be able to have that error in a place where you can actually debug it. So it needs to be alongside your code and it needs to be alongside some debugging tools. Otherwise, you're not going to be able to inspect the information that you need to inspect. So there's a few ways to reproduce issues. You can use a debugging recorder like Replay. So I'll be showing how to do that later on in this session. You can run the version of the code base that has the bug locally. So for example, if there is a certain branch of your code base and you know that has the bug on it, you can pull that down, you can run it locally. Or if you're already working on the branch that has a bug, you can just run that locally on your machine and you'll be able to see the code that's executing as well as what's happening in the application. You can also create a minimal reproducible example using a code playground or a sandbox. So if you've ever reported a bug on GitHub, for example, maybe a tool that you've used or a library, sometimes they'll ask you to create the issue, to reproduce it in Code Sandbox or Replit or something similar, where you're essentially, instead of trying to replicate the entire code base, just making a small version of what's happening in order to isolate the bugs so that they can see it. So these are all varying levels of difficulty in reproducing the issue, but it is really the first step, because if you don't reproduce the issue, then you can't confirm that it's actually a bug in the first place. And then you also won't be able to inspect what's happening and what the root cause could be. It's the same thing if you're using a website and an error pops up, you have no context as to what that error is. You don't see the source code. You can't really change anything there. So having that reproducible example is the first step for sure. So the next thing is to identify expected behavior. So what is the application supposed to do? Sometimes there's this thing called the XY problem, where somebody comes to you with problem X, but really what they need solved is problem Y. So they may come to you and say, hey, like this form isn't working when I hit submit because my password has a special character in it. And you may think that to solve the problem, you need to change the error message on the UI. But really, it could be that the password validation is incorrect. Maybe it should allow special characters. So you really want to get a sense of what is supposed to be happening and to be able to define what the real problem is. So a bug is a coding error, right? So it's something that's happening in the program itself with the code. If you have a UX issue or product request, those aren't bugs. So a UX issue is something where, for example, the user's confused. Like they were typing in a form and they hit next, but they forgot to hit save first and it deletes all their information. That's terrible UX. It's not, you don't want your user to experience that. But if it's technically that's the way the application is supposed to work, that they're supposed to hit save before they hit next, then that's not actually a bug in the code. That is a design flaw, that is a UX issue. So that's not something that you would, go in and debug and find an error in the code. That's something that you would, route to a UX or design team to evaluate. Same thing with product requests. If someone is like, oh, I really wish that it did this, Again, that's not a bug, that's not an error, that's just expected behavior. So it's important to know what your application is supposed to be doing and what the expected behavior is in order to know, is this really a bug? And then the other part of that is to be able to compare what working looks like versus what doesn't, like what it doesn't look like, what is broken look like. And then I don't know if somebody needs to mute. I'm hearing some background noise. So just and so again, what is the process when it works, right? So that's to be able to compare. And the way that we then take that information is we define what the actual problem as specific as possible. What are we trying to fix? You don't want to go in with a really broad scope, because then it's going to be that's how you end up spending 6 hours debugging a single issue, because you don't know where to start. So you just kind of start really broad and it takes much, much longer. There's this kind of algorithm about a phone book. And if you had to find a name in a phone book, and it has to do with sorting, right? So would you start on page 1 and go through every single page? If you know that the name starts with an M, for example, maybe you go ahead and you get rid of all of the letters before that, and then you start at M. And so if you know what the problem is more specifically, you can dive right into that section versus starting at the beginning and going through every single page of the phone book. So what we're really looking at is, how does the bug behavior deviate from expected behavior, right? So for example, you may have seen this in GitHub issues as well, this type of template where the expected behavior may be something like the app validates credit card number as 16 digits before processing. But what's actually happening is the app tries to process a credit card number with less than 16 digits and the payment processor fails. So we know what's supposed to be happening and we know what's actually happening. And we're able to then narrow in as much as possible on that specific behavior. So for example, instead of taking a look at the entire credit card form process, we can narrow right in on that validation aspect of it, because we know that that's the difference in the error and the expected behavior. Okay, and the next step is to isolate the issue, right? So we're talking about getting as specific as possible, narrowing it down. So where does the problem occur? This is an example of a potential flow that you may see in any application. So if you, for example, are clicking a button to process a payment, all of these things and more could potentially happen. You have your component element, you have your button. You click on it, there's an event handler function. That event handler function may update your state management tool if you're using state, if you're using hooks, if you're using a state, something like an X state. Then your state management may then have make an API call to a backend. Your API then may process some business logic in a controller. Then it may ping out a third-party API. Then it may update the database with the results of that, send the response back to your front end via the API. Then your front end may handle that response, re-update your state management, and then update the component, the button, with a success message or a failed message. So if you have a bug anywhere in this process, it could take a long time to narrow in and to understand. Like if you had to go through every single part of this code line by line and try to find where the error was, that's going to be a much more daunting task than if you're able to narrow in specifically where the bug might be happening. And so how do we do that, right? So first thing that you can do is look at the error message in a call stack, right? So if you do have an error message, not every bug does. Sometimes bugs, it's just you click on something, nothing happens, or the wrong thing happens. But if you do have an error message, you can trace the call stack to see what code was executing at the time the error occurred. You can also evaluate what lines of code executed. So something that you can do in replay is you can record the issue, and then you can hover over any line of code and you can see how many times executed or whether it was not hit at all. So you're able to kind of like narrow down to the code that actually took place when the bug occurred. This can also be helpful if you validate working code. So if we go back to our image here, And we're able to, again, tear out parts of the phone book, right? If we're able to say, okay, you know what, our click handler had the correct had the correct information. The state management took the right information from the form. Our API call went out correctly. But something happened in our business logic and the response didn't come back the right way. Then we can strip that out and narrow in on our back end. Or if we are able to see that the API call went out and the response came back fine, but we take a look at the state management of the response handler and see that maybe it didn't update the state correctly, then we can focus in on the logic around our state management. And so the more of these buckets that you can knock off and cross out by validating that they're working as expected, then it's going to be easier for you to narrow in on where the actual bug could be. Okay, and then next step is to trace the root cause. So you want to follow the code to the source of the bug, right? And so what you're going to do is once you've narrowed in on your sections, maybe like we said, it has to do with how your application is updating its state. You want to validate the code functionality at each step. So you can do this with something like breakpoints, or by stepping over the code, or in replay, you can see how many times a function executed and what the values were at those times. But you're essentially going to validate at each step to see where it goes wrong. You're going to want to examine what parameters are going into your functions. This is a really common bug where you are passing in the wrong value or the wrong type. If you're using something like TypeScript, this will help you kind of find these types of bugs. But for example, if a function is an add function, it's a math function, and you're passing in a string, that could cause problems. So understanding the values and the types that you're passing into functions is one area that you would want to validate as you go along. Another is return values. So if you have a function that's returning undefined, you usually don't want that. Typically, a function is returning a value that you're then using somewhere else. So that would help you narrow in on, okay, if this function is returning undefined, something must be going wrong inside that function. Or if this function is returning something, but it's the same value that I passed in and nothing changed, that could be an issue. If it's returning the wrong type, so if it's returning a string, but it should be returning the sum of two numbers, then that would be an issue. So you want to examine what values that your functions are returning to make sure that they line up with what's expected of the code. You also want to examine control flow logic. So control flow logic are things like loops, if-then statements, callbacks, anything that has to do with the flow of how your code is executing. This is helpful to see, for example, if lines are being skipped over. If you have an if statement, how is it evaluating? Is it evaluating correctly, or are you skipping over the first block when it should be true? So understanding what is running, how things are evaluating in those decisions. If you have a race condition between two different types of control flow logic, you have anything that's async that isn't handled correctly, that is another really common source of bugs. And then again, all of this is in a service of identifying when the bug deviates from expectations. So it's like you're following the trail of footprints from the application code and finding where it goes off path, finding where it deviates from what you expect it to do. And then when you see that deviation, that is where you can continue to trace it down to the source of your bug. All right, and then after that, you take a look at some solutions. Where do we go from here once you found your bug? You want to understand the scope of the bug. Is it one line that needs to be fixed, or is it something that is a much bigger problem? Also want to understand any areas of the code base that could be impacted by changes. If you make a change to solve a bug, are you then creating another bug elsewhere? That's something to keep in mind. Also, a bug could be an indicator of larger underlying issues. For example, if you spot a race condition with your state management, it could be that maybe you're not handling state changes very well. Maybe you need to introduce a reducer. Maybe you need to approach that a different way. And then, what opportunities for improvement are there? maybe it is something where you're seeing a lot of bugs related to types of parameters being passed into functions. Maybe it's an opportunity that you do want to introduce TypeScript or something to check that. Maybe you don't have good error handling and an error throws and your application crashes. Maybe there's an opportunity there to introduce some better error handling and show helpful error messages, for example. So all of these are things that you want to think about and take into consideration and collaborate on with your team or other developers in order to understand how best to fix the bug. You don't necessarily always just want to go in and be like, okay, like I see it. Let me just kind of like slap a solution on and see what happens, unless you have really good testing in place to ensure that you're not breaking something somewhere else. All right, so we covered a lot. I want to go ahead and dive into an example. So this is in the slides, which we will share. They are open. They're all public slides. There's a link here to a replay. But I'm going to go ahead and do it myself so you can see what the process looks like. This is a React calculator. It is actually just from the React docs as an example. Like if you wanted to check, you can fork it on GitHub and you can see the code yourself. I have it running locally on my computer. And I want to just demonstrate that this application has a bug. I didn't put the bug in there, it already had it in there. But you know, we can kind of see if we do 4 + 4, that works fine. But if we divide by 0, which as we know in math, you cannot divide by 0, I get an error. So I want to debug this error. So to do that, the first step that I need is a reproducible example, right? And so I'm going to go ahead and record this bug in replay so that we have a reproducible example. So this is the replay browser. Replay allows you to essentially visit any site and record it. And what it's doing is it's recording the entire browser session. So it's recording my click events, it's recording what's happening in the DOM. It's also recording the code, the JavaScript and everything behind it that's powering the application. This makes it really easy to debug after the fact without having to recompile every time. So I'm gonna go ahead and hit record up here in the corner, and I'm gonna go ahead and do my bug. So let's say it's just a double check, 2 + 2 = 4. And then 8 divided by 0, and then I get my error. Okay, and then I'm going to go ahead and hit stop, and it's going to update my my recording here. I'm going to go ahead and save it, and I'm going to go ahead and yeah, we'll go ahead and click save. So what this is going to do is it's going to take me to my replay. So my replay is essentially a recording of the bug that's occurred and everything that goes along with it. So we can, we can play it again. We can see a video of what's happening in the DOM as I'm going through. We can see all my clicks that are happening here. It's recorded all my click events. And then we can see the error as it occurs. This is the viewer mode. I'm going to go ahead and toggle over to DevTools. So DevTools gives us a lot more functionality. It's going to look very similar if you ever use like browser debugging tools or like VS Code or IDE debugging tools. It has all of those built into the recording itself so that you can do everything in one screen. So you don't have to pull up the code in your IDE, then also have the browser open, and then also hit play and make changes every single time. So just to give you a quick tour of what we're looking at, we have our video up here. I can add comments as to the video. We also have a console, which is what you would typically see. I can check this errors and I can see the console, the errors that are logged to the console. I also have my timeline here, so I can click on different areas and I can see what's happening during the time in that recording. I'm going to go ahead and add a comment when we hit our error. So here, I'm just going to go ahead and add a comment and say error occurs here. And this is just something that I use to kind of help me keep track. So we have the reproducible issue, right? We have the bug. So what's the next step is going to be, what was the expected behavior, right? What do we expect this application to do? So my initial thought was, okay, we don't have any kind of handling for division by 0. That's an error in this app. And that was my kind of initial thought that I had. But if I kind of go back to the big screen here and I look at my call stack, if I look at this error, I can see that there is a line 2 or 3 lines above that says alert divide by 0 error, return 0. So that to me actually indicates that there is functionality in this app to handle divide by 0 errors, but it's not working for some reason. So my initial thought was the expected behavior is that something, it just didn't have a case to handle it. But once I actually looked at it a little bit closer, I realized that there is a case to handle it, but it's not, that's where it's deviating from. So let's go ahead and take a look at that. So with replay, I can actually like rewind to this line here in the console. Oops. And I'm going to go ahead and come here to the error itself. Fast forward to the error here, and then here's my call stack, and I can see that my error here is in this operate function. And I can click directly on any of these lines, and it'll take me directly to the source code here. So again, everything is recorded from the browser, including your JavaScript code. So your JavaScript code is in the browser. Like whenever you're visiting any site, I could be recording like google.com, and the JavaScript exists. And so that's how Replay is able to record everything. So we can see here that we have a divide by 0 error that's happening in this like big.js file. And then we can trace that up to our operate function. And this is the line here where I see that we have, if 2, which is the second number, equals 0, then we're supposed to get a divide by 0 error. But as I hover over this line, I can see that it has 0 hits. So hopefully you can see that okay on my screen, that the font's big enough. But the little tooltip that appears says 0 hits. So these 2 lines are supposed to hit, but they're not. So I'm just gonna go ahead and add a comment here and say divide by 0 error does not hit. Oops, sorry, I hit a button on my keyboard. Okay, so now we're able to kind of isolate the issue more, right? So we reproduced the issue, we understood the expected behavior, that there is a divide by 0 error handler, but it's not executing. So now we can actually like isolate and the issue and dig in to this specific part of the code. So it has nothing to do with like the computation logic. It has nothing to do so we don't have to go in and like change the library that we're using the math for. We have a case to handle it. Why is it not working? So we're gonna go ahead and trace that back down, right? And so what I kind of want to see is we're going to trace this up. So we have here if 2 equals 0, and this is a control flow logic handler, right? An if statement has to do with what lines of code are going to be executing based on logic. And we can see here if 2 equals 0, and this does have 1 hit. So it did, have this line and evaluated. I hit the little plus line, and what that does is it opens up a print statement box that lets me evaluate how many times this occurred. So it's occurred 1 time, and I can rewind to that point in the DOM, and you can see it happened when I hit the equals button. It evaluated. Now that I'm locked in at this point in time, I can actually hover over my values and see what they are at that point in time. So I could also log them out to the console. So if I wanted to, I could say 2 and hit save. And I'm going to go ahead and hide my errors just to keep this clean. But what this did was it logged to the console the name of our function and then the value for 2. So I can see here that my value for 2 is an object of some sort. I can see that it does have a 0 here, but it's not a 0 itself. It's an object. And we're comparing 2 to 0. So if it's an object compared to a string of 0, that's why it's failing. So I'm going to go ahead and add a comment here too, and just say we are comparing an object to a string of 0. fails. Check. So why is this an object? I'm assuming it's supposed to be a number, or a string of a number at least, to see if it's 0. So let's go ahead and continue to trace this back up, right? So we could take a look at the call stack. So we can see here that we're in this operate function, which comes from the calculate function. We can also use these buttons here to step back and step in. So if 2 equals 0, let's go ahead and step back up. So where is 2 being defined? So we can see here on line 5 that 2 is being defined by this function here. So this is a function called big, and it's taking in number 2 and an operation. And number 2 and operation are being passed in here into our operate function. Again, since we're locked in a moment of time, in replay, we can hover over these and see what the values are. So I can see that my first number is 8, which makes sense. That's the number that I started to divide. 0 is number 2. So I was dividing by 0, and it is a string of 0. And our operation is divide. So if that's the case, number 2, and I can see here, is also 0. So again, we're tracing back to find where it deviates. This all makes sense so far. So what's happening is number 2 is 0 here, but it's resolving here, if we step over to the next line, to an object. Okay, so this is essentially the source of our error, right? We were able to hone in and kind of rule things out. We ruled out that there was an issue with what was being passed into the function. We evaluated our parameter values. We saw that number 1 was correct, number 2 was correct, and operation was correct. That means that everything above that we can rule out, because we know, okay, it's passing in the correct values. We don't have to think about calculate. We don't have to think about handle click, all of these other functions higher up on the call stack. We know that something goes wrong here. So that means that we're able to narrow in on just these few lines of code to see what's going on. So we've already been able to, negate these wide swaths of the application and focus it on this. So now we're able to go in just to the specific line now, right? So we have this line here, const2, and it happens 2 times. And let's go ahead and see, like, what is this big function? I'm going to go ahead and log it. So you can actually just log the function to the console. Oh, here, sorry, just big, not the function name. And then let me go ahead and, it's because I'm not logged in. So once you're logged, you have to be logged in at a point in time. And then I'm going to go ahead and get that to come through. And so I'm going to lock at the point of time. I'm going to go ahead and log number 2 and my operation. And then I'm going to add a comment here, or comma there. And then here, I'm going to fast forward. And now I'm going to go ahead and do my big function here. So big is not defined. So we're actually importing big. So we can see here, we're importing big from big.js. And for what's happening here is big is returning an object. So we're able to see here that 2 is coming back as this object, and we can evaluate 2 in our console. And we can see that it has a constructor, which is function big of a number. And we can even go deeper into what this function is. We can see that it takes an argument and then it has a length of 1, but it's returning the object itself, right? So it's by calling this value here, we're getting 2. And so if I were to do 2.to string, boom, now I can see that it's 0, right? So what's happening is we are returning the object as that variable, but really we need to be grabbing the string off of it. So to.toString, which I'm evaluating my console, I can see is 0. So if we were to update to be the value of this function, dot to string, or like we do have on here in the other lines, we can see here on line 7, on line 10, and line 13, we have this to string, but we don't have it for our function here. So this is really essentially where we have an inconsistency, right? So this behavior is working. It has the to string. This behavior down here is working and it has the dot to string. But on this line on 16, we don't have to string after R2. So I'm gonna go ahead and add a comment there. No dot to string on 2 results in object being evaluated. Okay, so that is an example of now we have traced the bug back to its source. And we also talked about some potential solutions, right? We could change, so this is understanding the impact of what potential solutions could be. If we were to change this to dot string and just return like the to string on this line, that would actually break these lines because these lines already have dot to string evaluated. So my initial thought of saying, oh, we need to return the string, not the object, is actually incorrect because that would cause more lines to break. So the real fix would be to make this line 16 consistent with the other lines in this function and add to string directly onto that value rather than changing it at the source. So when you're thinking about potential solutions, it is important to think about how things will affect other areas of the code base, other parts of the application. A couple of things I wanted to show you too, just while we have replay open. We didn't need to get into this, but I wanted to show how this works as well. I mentioned that because we were able to isolate to our operate function, we didn't have a need to go into our handle clicks. But a lot of times when you're debugging a React application, click handlers and state update is something that you'll encounter really frequently. So this is our click handler, the first one. It's defined in our button, but really it's taking a prop of click handler coming from our app. So this is our click handler that's being defined in our React application, and it's essentially setting our state. You can also see this information using the Reacts tab here in replay. So the Reacts tab is just like React DevTools in a browser. So if you've used React DevTools in a browser, or even Vue DevTools if you've done Vue development before, this is the same concept. It essentially shows you all of your application components and what the value is at given points in time. The difference is that because it's replay and it's a recording, the values are going to change depending on what point in time you are. So, for example, I can see my click handler in my app. So in my app component, I have my state. I have values for next, which is essentially whatever button is currently stored in our calculator. I have the operation, and then I have the total, which is the current running total. And as I move through different points in my application and I come back into app, it changes, right? So here our state is 8, null, and null. So I can even like go to a click and see how that click impacts my state. I can go to my next click and I can see how did my state update. I can go to the next click, how did my state update? So this is really helpful if you're having issues with state updates or with click handlers to be able to trace through what's happening in your React component at different points in time. And then we can also, for example, log to the console here. I'm going to go ahead and clear the other ones that I have open and clear those too. So for example, we have our click handler was hit 9 times. I can go ahead and log what my state was at each of those instances, and I can navigate through them. So I can rewind to the beginning and where my state was null for everything. After my first click, I have a value of 2 in next. After my next click, I have an operation stored. And this not only helps me debug if I have issues, but it helps me to understand how my application works. So again, this is not an application that I built. It was something that I pulled down from the React docs. But in order to debug it, I needed to give myself some quick sense of the context of it, of how it worked. So by kind of navigating through these, I was able to see, okay, so handle click is updating my state each time. And it's updating my state based on this kind of calculate function, right? And a button name. I can see what the button name is. I can see what my state is. And from there, I dug in. I was like, okay, so what's this calculate function? And I essentially just searched, and you can search for a function. And again, because all of our source code is captured, I was able to come in here and see, okay, so there's a calculate function that has our business logic and trace that down. You know, if I had an issue with my API, I can view all my network calls. I can click in and see, you know, any API calls that took place. This is a front end only application, so there's not really a lot going on. But you can see the request and response bodies. You can see the status code. So if you have a 400 error or something coming back, you're able to understand that. And then you also have your element picker, just like how you would see in a debugging tools in a browser. This allows me to click on a button, for example, and I can see event listeners that are attached to it. I can see the CSS rules that are applied to it. And I can see the layout information for it, such as the box model properties, and then also the dimensions. So right, so going back to our slides, like I said, that example, this link here is another link to a replay of the same error that has some comments to kind of guide you along the process. So the nice thing about a replay too is that it just creates a link that you can share. So that recording exists. You can open it in any browser. You don't have to open it in the replay browser, but you could share this link with anybody and they have access to all of the code, the debugging tools, comments that you've added. And so here you can open this one up and you can trace the comments and get a sense of, you know, what's happening here with the error if you want to play around with that yourself. Last thing I wanted to share is some resources. So we covered quite a bit today. Debugging, I know, can still feel very daunting, but I have found that it works a lot better when you do it with other people. I feel like debugging is one of those things that people tend to isolate to do, and they just want to get it over as quickly as possible, and they don't want to ask for help. But I have found that when I do ask for help, it becomes a much better experience. And so the first resource here, all of these are just tiny URLs, but they're easy to find, is Debug on Twitter. So there is a debugging Twitter community that we started, and it essentially is a place where you can ask questions, you can share bugs that you've encountered. If you find a good debugging resource, you can join us on Twitter, you can join the community. It's essentially a place where you can just ask questions, share, and then also share wins. You know, if you solve a bug, we'll celebrate with you. So that is tinyurl.com/debug on Twitter. The next is our replay examples page. So this is a link to our documentation. I mentioned one of the things that I do is working on our examples. This has videos, replays, and then also tutorials. We are really focused on helping people learn how to debug the right way. So for example, there is an article here on debugging CSS if you run into issues with CSS. But what I have found is that understanding how people approach bugs, seeing that debugging process in action, helps you to develop that skill set and learn how to approach it with your own bugs. And then finally, we have a tinyurl.com/asmarkdebugging. This is just a really great blog post around debugging advice. And then also, there's some tales of debugging. So there's a couple of stories here around debugging scenarios that he's encountered in kind of real world examples. And then last but not least, I did put a link here to our Twitch channel. So I do Twitch streams to replay every Friday. We have our replay office hours, and we talk about new features in the product, but I also spend time doing live debugging. So last week was the first week that we did this on Twitch. Previously, we were doing a different format. And I did some live debugging on a bug in replay. So if you ever want to kind of see debugging in action, see some real world examples, you can watch those on Friday at 2 o'clock Eastern time, or you can also watch the recordings anytime at twitch.tv/replyio. Awesome. So with the time that we have left, I was wondering if anybody had any questions. Hopefully everyone found this helpful. Hopefully you will come away feeling a little bit more confident about debugging your own applications. One thing that's also helpful that I have found is taking a look at other people's bugs, right? If you are an open source contributor, or if you're interested in contributing to open source, you can take a look at what bugs have been reported, see if you can try and practice debugging them yourself. That'll just help to sharpen those skills. So great, awesome. Well, thank you everyone for the good questions. And like I said, hopefully that we'll see you online with your own bugs, and have a great day. Cheers, everyone.